Hello, attendees. We're going to give it another minute to make sure we can get everybody can get online before we get started. So we'll be back with you in just 1 minute. Thank you. Okay, I think we'll get started this morning or this afternoon. Good afternoon and welcome to today's webinar, Future Robot Designs, New Connectors that Improve Board Density, Thermal, and Vibration Challenges, sponsored by the following Hiroshi franchise distributors: DigiKey, Mauser, Future Electronics, and Highland Electronics, who are authorized to sell the portfolio of Hiroshi Interconnect products. I'm Bill Kysiak, and I will be your moderator today. We have a few brief announcements before we begin. First, this webinar is designed to be interactive, and we encourage participation in the Q&A session that will take place at the end of the presentation. You can submit questions at any time in the chat area, and please note that we'll get to as many questions as we can in the time that we have left at the end of the program. However, if we don't get to your question today, someone will get back to you after the program has ended. If you want to view in full screen mode, click on the red tab on the right side of your screen. And now for today's presentation, Future Robot Designs. Discussing today's topic is Joe Quada, Industrial Segment Manager at Hiroshi. Joe has a graduate degree from the University of British Columbia with a Bachelor of Arts in Human Kinetics. Joining Joe will be Chris Laddick, Business Development Manager, who graduated from Gettysburg College with a Bachelor of Arts in Physics. And Bill McKillop, Interconnect Technology and Technical Support Manager at Hiroshi, who has a BSEE from Northeastern University in Boston. Collectively, Joe, Chris, Bill, and myself have over 90 years of experience in the interconnect industry. It's with great pleasure I now turn this special session over to Joe. Joe, take it away.
Thank you very much, Bill. So thank you very much for joining this webinar. I'm very pleased to have this opportunity with you today, even in this extreme special situation that we face now. However, we are here, and this proves that nothing can stop our endless inquiry and full of curiosity. So please let me introduce Chris Laddick. Chris is our business development manager. He is the specialist on the robotic market, and he will navigate us for new findings in this webinar today. So Chris, all yours.
Thanks, Joe. At Hiroshi, we greatly appreciate the opportunity to meet with our customers and have technical discussions. This is the origin and the impetus for new product development. And through collaboration, we find innovation. Hopefully we can meet in the future. Please enjoy today's presentation.
Hi, I'm Bill McKillop, Interconnect Technology Manager at Hiroshi Electric USA. Today, I would like to talk about connector trends in robotic applications. These topics include board density, high-speed transmission, connector shielding, high-temperature vibration, and a few application examples at the end. When we engage with our customers that manufacture robots, we find a common theme: the need for more speed and intelligence and more power on smaller volumes of space. These needs are pushing connectors to the limit and driving innovation in connector technology. If we look inside at a traditional control board, we find that legacy connectors limit your design options to a square box and to add more function, your robot would likely need to grow in size. This can also limit your ability to employ the same main control board across multiple platforms that have different form factors. Hirose has developed our FunctionMax line of board-to-board connectors with features that increase design flexibility. These fine-pitch, high-performance connectors permit much higher density, up to 3 times more than a standard half-pitch 50,000 centerline connector in the same footprint. With different mounting options available in the FunctionMax family of connectors, you can stack multiple circuit boards on top of each other. You can attach circuit boards in coplanar or in right angle configurations, and you can separate your power from your signals on the same board. Now, one common motherboard can be used across multiple platforms with long-term reliability. The FX23 connector shown here is a very popular series with many features in a small package. And it is no coincidence that it is the floating feature that gets the most attention. Let's discuss the floating technology shown here. Some FunctionMax series connectors allow alignment compensation by either an embedded floating structure or an integral misalignment absorption technology that allows the connector to absorb tolerance stack-ups. Another benefit of the floating feature is it allows multiple connectors to be used on the same board. These connectors contribute to the device design by absorbing assembly errors and help to reduce the need for expensive corrective rework operation. Let's talk about high speed. With high-speed protocols such as USB, PCI Express, GMSL2, MIPI, Gigabit Ethernet, and others, connectors must meet increasing high-speed specifications. The contacts are the engine of the interconnect system, and we commit research and development to get the best performance in the smallest package. If we look inside an FX18 coplanar connector, we see the engineering features that permit a speed rating of 10 gigabits per second. This includes controlled contact geometry and pitch for impedance matching, isolated and opposed differential pairs which reduce crosstalk, opposed contact gull wing SMT leads that equalize lengths to reduce differential skew, and ground contacts in between adjacent differential pairs also reduces crosstalk. Hirose has high-speed SI labs with the ability to offer simulation data for your specific high-speed application. Now let's talk about EMC. EMC is becoming a prevalent topic in robotic discussions, and new connector designs are addressing this issue. The newly released KP27F is a full shield board-to-board connector that has the floating feature, and it can operate at high temperatures up to 125 degrees C. And it has 4 separate power contacts to carry an additional 12 amps of current. These power contacts are cleverly located in the guideposts. The iX Industrial Type A key is the new Ethernet connector that has become popular in robotics because of its robust performance and smaller size. It is also an I/O connector that replaces the traditional RJ45 in half the space with its Type B key, and can replace lighter-duty USB connectors. The full shield design can transmit speeds up to 10 gigabits per second and meets IEC specifications for Ethernet. Another unique feature is that the right-angle plugs are also available that continue the shielding throughout the cable to the board. Let's talk about thermal considerations. In the automotive world, we have seen operating temperatures increase from 85 to 105 to 125 degrees C. And now, some applications are specifying 140 degrees Celsius. These extreme temperatures require extensive research and development, not only in the raw materials, but also in the contact system and the supporting structure. The connector must also survive severe shock and vibration and corrosion and other extreme criteria usually found in motor applications. Typically, we develop a new connector for extreme applications, but in some cases, we're able to modify an existing product. The Hirose DF40 series is a very popular connector for many different applications, but our customer needed to increase the operating temperature to meet their automotive requirement. By carefully evaluating the contact system, its spring properties, and the normal force, we were able to redesign the contact spring mechanism and increase its operating temperature by 40 degrees C to 125 C. We recently developed the FX26 floating board-to-board connector for a higher temperature EV inverter that uses high-power IGBTs. It has the ability to operate in environments up to 140 degrees Celsius. Our engineering team developed a contact that allows pressure to be received at the metal spring mechanism and not the plastic housing. Therefore, there is no concern that the contact pressure will decrease due to plastic deformation caused by higher temperatures. Additionally, the two-point contact design enhances reliability in shock and vibration testing. Our DF60 is a popular choice for robots because it is a robust solution for 8 to 12 gauge wire, for wire to board, and inline wire-to-wire applications. Its most important feature, however, is that its size is the smallest in the industry for a 65 amp power connector. Smaller components and the ability to adjust your stack heights in board-to-board connectors allow you to get more efficiency in cooling airflow. This will extend the life of all components in the application. Let's talk about vibration. Vibration is another concern in any robot. From the initial shipping phase of the new machine being delivered to the completion of its service life, vibration can destroy electrical systems if not properly designed for. The previously mentioned FX26 board-to-board connector series has a unique feature to resist damage from vibration. In the Z-axis, the mated contacts move together as a unit, thereby preventing damage from mating point vibration and long-term fretting corrosion issues. We have compared the FX26 connector with and without this vibration absorption feature, and in less than 30 minutes you can see the difference in the test results. The FX26 performs excellently in high vibration applications. Our ZEO5 is a 2mm wire-to-board connector. It has outstanding performance in a very small package. It has several features that give it resistance to vibration. The redundant double-layer spring mechanism in the female contact maintains excellent normal force in high vibration applications. In the inverted view, we can see the female has 2 embossed contact areas opposed to the spring contact point. This gives a total of 3 contact points to ensure a stable connection. Another feature of the ZEO5 is the internal rib that controls the clearance between the mated connector housing halves. This minimizes movement between the connectors and prevents damage during vibration. When we compare the ZEO5 to traditional connectors, we see a significant improvement in contact resistance during high temperature and during high vibration applications. For the next few slides, we're just going to run through some application examples where these Hirose products can be used. LiDAR, millimeter wave radar, cameras, sensing cameras, inverters, converters, batteries, ECUs, robotic controllers, and more. Thank you for watching, and for more information on these products or any other Hirose product, please contact us at hirose.com.
Well, thank you, Bill. And we'd now like to open it up for Q&A. If we have any questions, please type it in the chat area. Chat area on the website, that is. I've had a couple that have come in during the course of the presentation. Let's see if I can get a couple up here. The first one I'm looking at here was a question had to do with the IX connector. Can the IX connector use power over Ethernet? Chris or Joe, can you help us with that?
Sure. I think that's a good question. Thank you very much. So yes, so you can use IX with power over Ethernet, and since IX passes the latest IEEE 802.3 BT, so you can use IX with PoE options. Thank you very much.
Great. Thanks, Joe. The next one I've got here is has to do with the DF60 connector. Does the DF60 have fingerprint protection?
I think that's another good question. Thank you very much for asking that. The answer is yes. So we developed the finger protection version for DF60. And then currently 3 positions for header and inline plug are available in the market.
Great. Okay. And we just had another question about IX come in. Are there any plans to introduce an IX connector with integrated magnetics?
Yes, good question. We get that asked quite a bit. We are working on integrating some magnetics. Obviously, there's a challenge on the package size of the connector, adding more componentry to it. So we are working with the company right now to look at that option. So we'll follow up with more details as that progresses along.
Thanks, Chris. Do we have any guesstimated timing on that by any chance?
Joe, you might want to help me out on that one. I couldn't pinpoint an actual date.
Actual date still TBD. So we will keep you posted. So let us reach out to you, and then we will discuss about that more details.
Okay, thank you. Now we have another question about IX. How much time does it take to crimp a cable connector for the IX?
Good question. So there is a video out there that shows the assembly procedure for the IDC version of the iX. I believe it is quicker than a RJ45 assembly, but as far as an actual time, I don't have that at my fingertips of what it takes. I've done it personally. I've done both RJ45s and iX. I find the iX easier to assemble.
Chris, you said there's a video on it. Do you have any direction on where that video can be found?
It was on YouTube. I'll double check that to see if it's still posted, and we'll get that out to you.
Okay. All right, and I have here who requested that information, so we can probably get back to him directly. Great. Another question. Many supply chains are very impacted right now. How are Hirose lead times in comparison to pre-pandemic periods?
Ooh, touchy subject these days. So yes, obviously lead times are going the wrong direction. I think that's not unique to Hirose. It's compounded by some panic buying, shortage of raw materials, and just the recovering from the pandemic. So we handle it basically by product line, and we are working directly with our customers to try to manage that situation. But
Okay.
we'd have to look at each situation individually to give an exact answer.
All right. Yeah, so the person who requested that, if you could, if there's a specific series that you're interested in, if you let us know, I'm sure we can get back to you with that, after we research it. Got a question from someone named Robert here. The DF60 is a nice power connector. I'm seeing more wire-to-wire for outdoor applications. Will there be an IP-rated product on the Hirose roadmap anytime soon?
Yes, I believe so. So I know that's been discussed. Joe, maybe you can add some more information on this waterproof DF60.
Waterproof DF60, if I remember correctly, we've been discussing internally. Then hopefully it gets soon, but we still unfortunately still working on that, and we haven't had a specific schedule yet. So thank you very much for asking that. Then if possible, we would like to reach out to you and then discuss more later, more details with you.
Okay, we can, as you have more detail, we can get back to the requester on that. We have a question here. Are connectors available in different colors for to identify them for specific usage?
Yes. So in several of our wire-to-board series, DF60, DF22, DF62, DF63, we do have color options. Normally black is the standard color, but we do offer white or gray, and then red as an option in select sizes.
Okay, thank you, Chris. Question from John here. Are you working with any network equipment partners to develop off-the-shelf switches and routers utilizing the iX connector?
The shorter answer is yes. I don't know them by name off the top of my head, but there are some out there we can follow up with to get you that information. Okay.
Actually, we probably can't discuss the specific customer names, but just are we working on that application? So sounds like yes.
Yeah.
Great. And then there's another one. What vibration standard does Hirose test to?
Ooh, good question. Unfortunately, it's not a simple answer. It generally starts with the initial customer application where the specification is set. So for example, the ZE05 meets a European standard LV214. ZG05 meets 214 and also US CAR 2. Then if we would look at the FX26, that meets the customer, large automotive companies' internal specification. However, if we look at the actual testing parameters, it's very similar to MIL standard 202. So it does vary from connector to connector.
Okay, great. And with that, I think we're about out of questions. Are there any last minute questions before we wrap it up here? Okay, and with that, I'd like to thank you all for joining us today. We hope this webinar has been informative and you gained some ideas to help you with future robotic designs. And don't forget, follow Hirose on LinkedIn, Facebook, and YouTube. Good day and stay safe. Thank you. Bye-bye.